What's going on, everybody? My name is Kyle. In this video, we're going to be taking a walkthrough of an AWS data pipeline that I built myself. We're going to be walking through each step of the pipeline within the AWS console. We're going to be going over each service, how it relates to the project, and we're also going to show the interrelationships between the services, how they all link together. And at the end of this video, we're actually going to run the pipeline itself, so be sure to stick around for that too. At the start of this pipeline, we see on the left side of our architectural diagram here, we have a CSV file titled heart.csv. When this is uploaded to S3, it triggers the start of the pipeline. That action triggers a Lambda function, the purpose of which is to trigger a glue job. This glue job grabs the CSV file from S3, transforms the data within it, changes the file format, and then outputs that curated data file into a different folder in the same S3 bucket. When that file hits that specific folder, it triggers another Lambda function, this one far more complex than the first. This Lambda function grabs credentials, just a username and a password, that are stored in AWS Secrets Manager. It uses those credentials to authenticate to a SQL server. Once it's connected, it inserts the data from the curated file, thus completing the pipeline. So that's the simplest way that it can be explained. It takes data, extracts it, transforms it, then loads it to a new place, follows an ETL format. I do have to give a thank you to a person at my company. I work at Sandy Spring Bank. They just got acquired by Atlantic Union Bank, actually, so you may not be able to find them too easily online. Maybe you still will. I don't know if they're going to delete their website totally. The customer day one is in 10 days, so possibly very soon you won't be able to find it. But anyway, they called the help desk. They're a data engineer. They needed their account unlocked. We got talking a little bit. I expressed some interest in data engineering, and they were generous enough to tell me a little bit about what they do at the bank, how they move data, and they also suggested this project structure, which I was really interested in because they actually use this structure, something similar to this, to move data at the bank. So it's in a production environment. It's in use in an actual real life enterprise production environment. So as someone wanting to learn more about data engineering, this was a great first step. This was a great help to me. So to that person, I say thank you. You know who you are. And then without any more preamble, let's go ahead and move over to the AWS console, and we'll see how this thing works. So now that we're in the AWS console, I do just want to go over briefly how I'm going to be conducting this video. There are many different supporting aspects to this pipeline that are outside of the actual pipeline itself. For instance, IAM stands for Identity and Access Management. It's an AWS service, but IAM is also a practice, a department usually within every organization's IT department. The job of this is to provision access for different users, create user accounts themselves. Like when you join a company, you need access to their computer systems. IAM would make a user for you, and then you would use that user to log into the system. So for this project, I had to create different permissions for different services that allow them to interact with each other and interact with certain aspects of different services. I used least privilege access, which is a security practice. Basically means you only provision access to whatever the person or the function needs to perform their job function. So stuff like that, it's very important, but I'm not going to go into that in this video because I want the sole focus of this video to be on the actual functioning of the pipeline. So I just wanted to mention that. Just know that's what I'm going to be focusing on, but there was stuff like this that went into making this pipeline. So without any more information, I think that's everything I wanted to say before we really get started. We'll move over to the S3 console over here. And this is where the pipeline begins. So Amazon S3 is Amazon's storage solution. It's just cloud storage, and S3 stands for Simple Storage Service. Basically, if you want to store things in the cloud, files, videos, pictures, different types of data. They have a lot of different data types. This lets you store it, and it uses a flat structure, meaning that there's no typically in Windows, if you're on a Windows computer or Mac, you have different files. You have a root and a directory, a subdirectory. It's like a nested structure for storing data, different files. With S3, everything's stored at the same level within a bucket. There's no nesting. It appears like there are folders. Like if we go to my bucket, first DP 1333337, if we go in here, it looks like there are folders, but this is just for organizational purposes for me, so I can access the data in a clean way. It's really all at the same level, so that's an important thing to mention. So if we go into this folder here, raw, and then heart data, this is heart.csv. This is the CSV file that was on the left side of the screen from the architecture diagram. When you upload this, like if I click upload here, add files, and then choose heart.csv, if I were to hit open, that would trigger the start of the pipeline. So this is where it begins, right here in S3. So that is an important thing. This is where it begins. And when this file is uploaded to this specific path, raw heart data, if we move over to the Lambda console here, we can see my first Lambda function is called glue job trigger. A Lambda function, it's basically it's code that lets you do. You can do a lot of different things with it, but you don't have to worry about servers. It's serverless, so it's like on demand. It only runs when you want it to. When it's not running, it's just sitting there not doing anything, and it's not costing you anything either. So instead of like having a server that's running 24/7, you can just create a Lambda function, and it sits just sitting in the background and idle, just sitting idle, not incurring any cost. And then when you need it to perform something, you can call upon it with a trigger to trigger it, activate it. It does what it needs to do, and then it goes back to being idle. So it's very useful for many different things. And this is a really simple Lambda function. This is the entire function right here. It's in Python. So it imports Boto3, the AWS client, and it just really, all it does is just starts a glue job. So the job name is first DPETL. All it does is runs the glue job, and it outputs a status code. As long as it runs, it'll say start a glue job run, status code 200. So that's really all it does, and I'll show you how it links with the S3 folder that I just talked about before. So if we go to configuration and triggers, this is what triggers this Lambda function. So we can see it's my bucket, that same bucket name from before, and the event type is an S3 object created, which means that when that file is uploaded to that S3 folder, it's considered an object created, so that's the trigger, and it has to be within that folder. So this is the prefix here. This is the raw /heart data /. So the object has to be created within that folder to trigger this Lambda function. So the reason I didn't just have it in the general bucket, I could have had the object created within the bucket. This helps as far as security goes. So let's say you have somebody who needs to access only this folder, but you don't want them to access everything else within the bucket. This is useful for that. So this could be implemented in IAM as well. You could give them only access to that folder in the bucket. So this is another manifestation of just least privilege access here. So that's what triggers it. It's conveniently named triggers. So when a file's uploaded to that folder in S3, it triggers this Lambda function. And this Lambda function then triggers a glue job. So next we'll go to the glue console and we'll show you what that glue job does. Okay, so now we've moved over to the Glue Studio. Glue is an AWS service just for extracting, transforming, loading data, preparing data for data analytics. In my case, I used it to transform data in preparation to be inserted into a SQL server. So before we get into this, I just need to say that I did use AI in building the glue job and the Lambda function, and also for helping link things together. It helped me learn and be productive in a massive way. It's a huge lever for productivity if you use it correctly, which is how I used it. If you use it, say like maybe you're in college and you have AI, I don't know, write your homework for you, maybe write your English essay for you. It just fills out the answers and then submits it. That's not using it correctly. That'll make you more lazy. The way that I used it makes me more curious, and I'll speak more to that later in this video, but I did just have to be transparent on that. So as far as the job goes, these two are the same thing. That's why it's the same word with just a copy. I made a visual so you could actually see what's happening for the more non-technical people. So this is the entire glue job here. The first node, this is called a node, it's called glue heart source. The pathway is from that S3 bucket, our S3 bucket, and then that raw heart data folder. The format CSV. So this is what tells Glue where to get the data from. So it tells it where to go to get the file. This node is the heart transform node. The node's parent is the glue heart source node from before. So that just means this comes after that node. And I'll explain what this script means in a second. But just know this is where the actual changing of the data, the transformation, this node is where it takes place. This doesn't really, not really relevant to mention. It's just like a weird little formatting thing. And then this is the final step. This is the target node. So this tells Glue where to output the newly transformed data and the new file, because it does change. If we see the format's changed to JSON now. And it's within the S3 bucket, curated data. And then we can go and see actually in S3 our bucket, curated data, heartdisease.json, and this is where the actual file gets output to. So here's the new file, and then we'll go back to Glue really quick and just show the actual script. So this is that was for the more non-technical folks. This is for the more technical people. This is the script. So at the top here, we're just importing libraries, modules, and then we have one thing to note is that we're using PySpark. So when I made this job, the job type, I chose Spark, and Spark in this case, it means Apache Spark. PySpark is the Python API for Apache Spark. So it just allows developers to write, to use Apache Spark while writing in Python for Python applications. So that's why we import this. It's very necessary for this project. Here we define the schema for the data. So like numbers, age are integers, words are strings. This is important for keeping the data structure consistent, and it's relevant for when we apply it to the SQL server. So you'll see this again in the Lambda function. Down here is where the transform takes place. So the data, if I haven't mentioned already, the data file is just heart disease data. People have a heart attack, they come into the hospital, their age, sex, chest pain, cholesterol, different metrics are recorded. And all we're doing is just transforming where there are numbers, we're going to transform them to words. So like chest pain, CP stands for chest pain. In this data file, if it's a 0, 1, 2, or 3, those numbers all correspond to different types of chest pain: typical angina, atypical angina, asymptomatic. all I'm doing in this is just transforming the number to the word, to the corresponding word. So this would make it easier for data visualization later, like when maybe a data scientist goes to analyze this data, like a health researcher goes to analyze it. Instead of looking at a number, their data visualization will already have the word there, so that's one less step for them. And that's kind of the role of a data analyst, is to move, prepare, clean data and prepare it for use. So like if you're training an AI model on data, you need clean data. So that's why data engineer as a career field is expected to increase over the next 5 to 10 years because of the rise in AI. We need data engineers to clean all that data and prepare it for training AI models. But in any case, this is where the data transformation takes place. So this is what this is doing. It does it for CP, resting ECG, slope, thal, anywhere where there are numbers, where they correspond to words in the original data. This is the script for the node for the glue-hard source. We see it points at that S3 bucket folder where that original CSV file hits. So again, that's how it knows where to go grab that data. This is the transform node. It shows the source node as its parent node. And then down here, we have that little weird technical one, the collection node, select from collection node. And then right past that is the glue-hard target. This is the target node. It tells Glue where to output the data, like we saw before. And then here's the output path. And then that's the end of the job. So that's pretty much it. The next step is going to be going back to S3 and just showing you where that outputted data lands, and then explaining how that data or that file hitting that specific folder triggers the next Lambda function. So that's where we'll be headed next. Okay, so now we're back in S3. The glue job is run, and it's output the curated file into our S3 bucket here. And then it's set to go to the specific folder, the curated data folder. So we can open this. And then there's a subfolder here. We open this here and we find the actual JSON file. So this is the curated version that's going to be uptaken by the Lambda function. The data within this is then going to be inserted into the SQL server. So if we come over back to the Lambda console, we can show how that works. This was our first Lambda function. If we go here to our second Lambda function, this is the main function. You could say this is a very, very important part of the pipeline as well. There's the data is not being transformed here, but this is where the data moves from S3 to the Lambda function, or sorry, to the SQL server, and gets inserted into the SQL server. So very important part. I'm going to go through how this all works. I'm going to give a technical explanation, but first I do want to just give a non-technical explanation. So basically this Lambda function, this code here, what it's doing what it's doing is grabbing that JSON file from this location within S3. It then connects to a SQL server, and that SQL server runs on an EC2 instance. So it connects to that instance and then that SQL server, and it takes the data from that file and then inserts it into the SQL server. So in the simplest way that I can explain it, that's what it's doing. And now we'll give a more technical explanation for anyone interested. So we'll start with this import here. PyODBC, this is a Python Open Database Connection. It's just a Python module that allows you to use Python to connect to databases. So this was very important and crucial actually for moving the data. And that ODBC, remember that, because that'll come up again in just a moment here. So we'll start at the beginning where it actually grabs that file from S3. So we see here the bucket and the key. The bucket is the name of our bucket. The key is the folder within the bucket that contains the file. And notice we don't actually see the bucket name or the folders. We see like records here. If we go all the way to the bottom, this record section, it says the bucket name, and then the key here is the full folder, the file path with the actual file. So that's how the Lambda function knows to look in this location for this specific file. That's where that's recorded. Once it has the file, it does some things with JSON, reads the file, which happens here. It validates, cleans the data, and here it sets the maximum length for the columns. So this was a problem that I had when I was working with the data in the SQL Server. Some of the column lengths, like for thal, it was set to 20 instead of 30, and that caused the any row with a thal over 20 to not be inserted into the SQL Server. So I added this part to define the maximum length within the Lambda function, just to keep things consistent between the Lambda function and the SQL Server. Once that happens, it gets the SQL Server credentials, Microsoft SQL Server credentials to be more accurate, and it fetches them from Secrets Manager. And Secrets Manager is just an AWS service. It does one thing. We can see it has one tab, Secrets. So it lets you store anything that you want to keep secret. In this case, a username and a password. I wanted to use the best security practices for this project, so I stored them. I stored the password and the username for the SQL Server securely here. It uses this ARN, which is an Amazon resource name. It just defines a specific Amazon resource, and in this case, this just points to credentials that are stored here. And then we can see our username and password right here. So this is what it's grabbing, just the username and the password. And there's that same ARN, so it knows to get those credentials. And then here it defines, username, password. We'll see that later in the connection string. It does a network connectivity test between or to the SQL Server. Up at the top, I imported socket in order to just test the connection. That was one of the problems that it had. It was failing at the connection to the SQL Server. So I wanted to do a test before it actually connected to see if that was causing it to fail. So this is the private IP of the EC2 instance that the SQL Server runs on right here, and it's port 1433, which is the port that you use to connect to SQL. Right below here is a really important part of this Lambda function. This is the connection string. So this is where it's actually connecting to the SQL Server. I'll go over the driver in a second. That's a crucial piece of info. But the server, again, here's the same private IP from up here. This is the private IP again of the EC2 instance where the Microsoft SQL Server is running. The same port, 1433. The SQL port. Database is PipelineDB. This is our database name within our SQL Server where the data is going to be going. This FUID, FPWD, this is the username and the password that we grabbed up here earlier from Secrets Manager. So it knows to use that username and password that we previously grabbed, and that logs us into the SQL Server automatically. We don't have to type it in this way. So it automatically authenticates right here. And then we added an encrypt yes, trust server certificate yes. Without either of these, the pipeline wouldn't work. It failed on both these parts, so that was part of my debugging as well, figuring this out. So adding this was necessary to get it to run. And let me go over the driver here really quick. So the driver, in this case, it means the ODBC driver. More specifically, it's the driver for Microsoft SQL. So if we go over here, we're going to look at our Lambda layer. This is just a local file I have on my computer. ODBC driver layer updated 3. This is the final layer that I used. And I actually got this layer from this GitHub right here. So I tried building it myself, and I ran into all kinds of issues. And I'll explain that here now. So I had it structured, long story short, I had it structured the wrong way. Lambda has to pick up, it uses a specific path to pick up the locations of things within the Lambda layer. What finally wound up happening was that I was using a deployment package, and I was using var task when I should have been using opt/lib, which is what works for the Lambda layer. So let me show you what I mean by that, because that probably doesn't make sense just saying it. Okay, so if we go to this path within our Lambda layer, we find this file, odbcinst.ini. The purpose of this file is to tell the Lambda function where to find the driver that lets us connect to the SQL server. And this is the driver right here, lib Microsoft ODBC SQL 18.5 SO11. So that's the name of the driver, and it's an actual file that I'll show you in a second, but this is where it's located. Remember I said OPT just a second ago? I used to have this set to var task, which would work for a deployment package, but the way that I had it structured, it didn't work. So I ran into all kinds of errors. I had SQL cannot connect or cannot find driver, IM004, IM002 in the Lambda logs. I tried different runtime versions. I tried different Python runtime versions. I had to try changing. I changed the ODBC driver, or the SQL version rather, from 17 to 18, because I thought maybe it wasn't the latest version, which it turns out it wasn't. So I had to update that. I tried spinning up a Docker container to try and test if it could connect outside of Lambda to the SQL server, because Lambda wasn't connecting to the SQL server. I tried importing different libraries, PyArrow, Pandas, which I found out were actually not necessary. It turned out that those weren't necessary for this project. What else did I do? I spun up a Linux instance to download Unix ODBC and different dependencies and libraries that support this driver, and tried structuring those within a deployment package, Lambda layer, many different iterations of that. I made a Python test file on a Linux instance with just a connection string to see if that Linux instance, which I put in the same subnet within the same VPC as the SQL server, to try and just connect to the SQL server outside of Lambda, which actually worked. That was a big breakthrough in debugging when that worked. Those are just some of the things that I tried. It took probably 80% of the total time that I invested in this project just to get this Lambda function working. This is where I spent most of my time, just trying to get this Lambda function to connect to the SQL server. Once it connected, I just had to fix a few minor things, just changing some of the column lengths, like I mentioned earlier. Some of the max lengths were too short in the SQL server. I had to get it to connect. I also had to change things like settings on the SQL server. I had to turn SQL Server Browser on. I had to go into TCP in SQL Server Configuration Manager and set that port to 1433 and set the IP to my EC2's private IP. Or no, it was actually to my local machine's private IP. Or public IP, sorry. We'll go over that in a minute here when we actually connect to the SQL server, but I had to change some networking settings within the SQL server, do a few other things, and then let me show you also how I got this Lambda layer to work too. So if we see the driver path here, it's actually correct in this case. So we can go back over here. Microsoft MS ODB SQL 18 lib64. Same path. And then we see the driver's located right here, which is, this is the same file as this points to. So that's all good. But the issue also remains, how does Lambda know where to find this file? Because we can see in the connection string it has the same title. You know, this title matches up with the title of this file right here, which is how it knows that it's correct. But we don't have a place to point to here. It's not actually in the Lambda function. It's what's known as an environment variable. To my understanding, or at least how I use these, they just let you point at a specific place to look for a specific thing, like a file, without actually having to hard code it into the Lambda function. So in this instance, ODBC ini, OPT Microsoft, MS ODB SQL 18, etc., ODBC inst.ini. Where does that go? So you can see right here, same file, and all this is just pointing at the location of that file. So if you see Microsoft, MS ODB SQL 18, etc., same driver path, same path, and it just points to this file. And then that file then in turn points to where the ODBC driver is. Remember, that's the purpose of this file. It points to where the ODBC driver is, which is right here. So there's a bit of layering that takes place there, and it can get really messy just with the complexity of it. Like for instance, if we go back to our code, I still have an older before I upgraded, or updated rather, to the latest version of ODBC, I had the driver path set to an older driver, so 18.4, whereas my current driver is 18.5, and I actually still have it hard-coded into this Lambda function. I just wanted to leave it in there so I could show you guys an example of how this works. So even though this is hard-coded in, the environment variable, the way I have this set up, this overrules that. And this is also the wrong path too. This OPT /lib, this doesn't actually point to that. See, if we go in lib, it's not actually there. So if we go to our logs, we can see this is from a previous run. The ODBC driver is not found at OPT lib ms ODBC SQL 18.4. So it's not actually found there, but yet the Lambda function still runs. It still inserts the rows into the SQL server, and that's because the environment variable here overrules what's hard coded in here. And so this was set up specifically to test which path was working. So it's set up if this path fails, it then moves to the environment variable. So this had to be specifically set. This was one of the things that AI helped me with. And I mean, again, just as this is a good example of how it helps you learn new things. I didn't know how to debug very well before this. This is my first like major like heavily architecturally based project that required a lot of debugging. So now like I kind of know how to think when I go to write my next project. I wouldn't have known to set it up like that to test different things. Like if this fails, then try this. I would have like tried one or the other just with my instinct. So that's a good example here, and I wanted to leave that in there just to point that out. But anyway, we'll go back to the connection string, and then now that we're connected to the SQL server, we have to clear the heart disease table, which is the table within our database, which is pipeline. Our database, remember, is pipeline DB, and that's the database within our SQL server. And within that database, our table is called heart disease because it's heart disease data that we're inserting. And then here we use cursor, just delete. This is just a SQL command. Delete from pipeline.dbo heart disease, and it clears the table, making it clean for us to insert. And now we can insert our values into heart disease, or our data rather. This is an important part of the Lambda function. Cursor.execute, we're inserting into heart disease all 14 of our columns with the schema defined, integer, string, integer, just to keep things consistent and structured. And then here we close the connection once it's inserted, and that concludes the Lambda function. This right here, I just want to mention really quickly. I didn't actually use this, but it's another good example of how AI helped me learn. Grok wanted to try this to see if the problem was with the ODBC connection itself, and we couldn't actually place these logs in CloudWatch logs because for some reason they just won't go in there. We had to try and make a separate file within our S3 bucket to get the logs, but I didn't end up getting them. It wasn't necessary. But again, I left this in there just so I can remember for next time, like if I have a problem with the ODBC connection, I know now that I can go and find those, I can like get those logs to maybe try and figure that out. So again, that's another example of how AI helps you learn new things if you use it correctly. So yeah, that's a good example, and that's the end of the Lambda function pretty much. We already went over this part. So that got pretty technical. I mean, I think that's a good explanation of generally what it does and how that works. So we'll go ahead and move next to the SQL server itself. We'll start up the EC2 instance that has the SQL server, and we'll go in and just show you guys what is actually happening, what that looks like when that data gets inserted. So now we are over at the EC2 console. I'm not going to go into what EC2 is. You can just Google AWS EC2 to get a description of that. This video is going pretty long, so I'm going to wrap this up pretty quickly here. But one note I do need to make while the information is still fresh, in our Lambda function here, when it's inserting this data, it's also actually changing the column names of each column, each of the 14 columns. So the original CSV file, they're abbreviations, but it does change the name to its full form. So when we go to the SQL server in a second, you're going to see those names. I just didn't want there to be any confusion on that as to why they had the full names in the SQL server. So our instance where the SQL server is running is first dp_instance. It is a T3 small. I went with T3 micro at first, which is in the free tier, but it had a little bit of lag to it, so I just increased the size by 1. It's a Windows 2025 base AMI, and it runs in a VPC and subnet which I created myself and did all the networking for. The Lambda function, the last Lambda function, is in both the same VPC and subnet. So that's one thing to note. I just did that for security and ease of communication between the two services. So if we connect to our instance here, we're just going to use remote desktop protocol, and all I did was just click connect, clicked on RDP client. I decrypted the password and then just connected. So you can look up how to do that if you want. It's pretty simple. But this is the SQL server, or not the SQL server. This is the EC2 instance where the SQL server is running from. So we can open up what's called SQL Server Management Studio. I had to download this and install it. And before I did that, I also downloaded SQL Server Express 2022 because that's a free version and it was completely suitable for this project. And then we also need SQL Server Management Studio, which we're in right now, to interact with that SQL server. This is the SQL server. Within it is a databases folder. This is a database that I created, which, if you recall, is mentioned in the Lambda function connection string, pipeline DB. And this is our table within the database where the data actually goes to, titled heart disease. If we run a SQL query that selects all data from heart disease, we see there's nothing in here. That's because I cleared out this data manually, just so it's blank before we run the pipeline, which we're going to do in 1 second here. And we're going to see how this fills with data from our CSV file. But before we do that, I just have to mention I did do some things in SQL Server Config Manager. I had to turn on SQL Server Browser. I had to configure the TCP IP, turn that on, do some configuration. I had to change the SQL, the Microsoft ODBC version from 17 to 18. I had to uninstall 17 and then install 18. I deleted files from the registry, or keys from the registry for the old ODBC 17. So I'm not going to go into the details of how all that works. I just want to mention that I did that. I want to finish up the video here. So now that we've seen what the final destination is for our data, let's go back to the beginning of the pipeline and actually run this thing and see what it looks like. Okay, so we're back over at S3. We're going to start the pipeline now, and if we recall, we do that by going into the raw folder, heart data, and I deleted everything out of here. So we're going to upload, we're going to add files, and we're going to choose heart.csv. I click on upload, and the pipeline has begun. So if we remember, when this uploads, it triggers a Lambda function, a very small Lambda function. The only thing that Lambda function does is triggers a glue job. So we go back to our glue job, and we see it running here. And we can see 1450 corresponds to 250. So it just began running. We see the duration started 16 seconds ago. So it usually takes a minute 20, a minute 30 seconds to run. So if you're as sick of the sound of my voice as I am, you can feel free to skip ahead. Whenever you see succeeded right here, you can restart the video. But we'll just keep talking through it. I'm not going to skip. So with this project, I really wanted to get fundamental skills, like I said. I think with learning, it's good to start at as fundamental a level as possible. Get a broad knowledge within that, and that gives you the foundation to build up. So like an example could be the next project that I do. I can use this pipeline as part of it. For instance, I could make a web application with a nice looking user interface for perhaps like data analysts or data scientists, or maybe medical researchers that need to access the heart data. They can use this web app, and then this pipeline would be a back-end component of that web app. So There are a lot of other things I could do, like for instance, instead of manually uploading that CSV file, I could make a batch file and run. Oh, okay, that cut me off. So it's succeeded now. The glue job ran successfully. So if you remember, once the glue job runs, it outputs a second file back in S3 in our curated data heart_disease.json folder. And here's the file created today, 1451. It was just created. And remember, when that file hits this folder, it triggers the main Lambda function. So now it triggers this. So this Lambda function is currently running. And if we go over to CloudWatch logs, which is just all CloudWatch logs does in this instance, we use it for monitoring. And in this case, we're going to use it just to see the logs from our Lambda function, so we can actually see what happens when our Lambda function runs. So here are the latest logs. And if we go to the top, we can see right here Lambda function started. Yada, 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 yada. Downloading file from S3, it's downloaded successfully, reading JSON file, read 303 rows from JSON, fetching credentials from secrets manager, testing network connectivity, initiating connection attempt, successfully connected to the SQL server. Yay. And then all the way down here, we just have its inserting row. It repeats 303 times because that is how many rows of data that we have. And all the way at the bottom, we successfully inserted 303 rows into the SQL server. And then the next line is close the connection. So we close the connection to the SQL server, and then the Lambda function ends. So now, if we go back over to the SQL server, remember last time when we ran this query, there was no data. If we run the same query again, we can see all of our heart disease data, heart attack data rather. And it's in a nice, easy, readable form with full column headers, nice words here instead of numbers. And then say if I do make that that web app in that visualization that I'm talking about, we can just insert the data right into it, and it'll show up as a word in, say, like maybe a bar chart instead of having a number. So the data's been transformed, cleaned. The scheme has been defined. It's structured consistently, and we can see the pipeline was a success. All right, everybody, that is the end of this video. Thank you so much for watching. I'm going to put a link to my GitHub down below. Check that out. It's got this project, a few others, and will be updated in the future here. I also have a link below to my LinkedIn profile. Connect with me there. Shoot me a message. Also, please feel free to comment on this video. Be as blunt as you possibly can. Write how you truly felt. You loved it. You hated it. Let me know. I want to know how the thing that I put out into the world was received. So help me out there. Write a comment below. Whatever you want. Also, I know that the mic or audio quality on this video was not really the best. The microphone I'm using was $30, so I'm going to need to buy a new one, a much more expensive one, because this one is not really doing it for me. So just FYI, that will get better. That's about it, everybody. Thank you, and have a great day.